Okay.
So we are honored tonight to have Dr. Phil Kelton. Dr. Kelton received his Ph.D. in Computer Science and Astronomy from the University of Texas at Austin in the year 1979. He had a 32-year career with McDonald Observatory, during which he was a programmer, computing system manager, assistant director, and superintendent. His association with McDonald was primarily involved with large telescope technology and instrumentation, plus observatory and project management. He first took up amateur astronomy in the early 1960s and maintained that interest in parallel with his involvement in professional astronomy. After retiring in 2007, he continued to be involved in public outreach as a National Park astronomy volunteer, primarily at Black Canyon of the Gunnison National Park, as well as McDonald Observatory. He is also engaged extensively in astrotourism, especially in France and Europe. Please welcome Dr. Phil Kelton.
Okay, so as I said before, this is the fourth talk I've done for the Denver group, and it's a very different kind of talk, so I hope you enjoy it. This is a Gregorian telescope, and we'll see more of that later. Okay, so a little bit of introduction here. For 20 years, from 2000 to 2019, I traveled extensively in France and various places in Europe. And the reason for that is my wife was a French professor at the University of Texas for a very long time. The last 18 years, she was the director of the study abroad in France. And so all of those years, I went and visited in France, the first 6 or 7 just for maybe 2 weeks, but the last 12 or 13 for half the summer. So because of all of that traveling, I really got to see a lot of Europe. I also traveled a lot while working for McDonald in various places, had other travels, and so at some point I decided in my explorations of Europe that I should start exploring astronomy. So back in May of 2014, we used to spend with the students, we used to spend a week in Paris at the beginning of the program, so I decided I would just use my week in Paris to explore astronomy history, various interesting astronomers, places they worked, things they did. And the result of that was a talk I did called A Footloose Astronomer in Paris. So I created that kind of nickname, Footloose Astronomer. And I've done several others. So that's the origin of this talk. And virtually all of the talks, all of the photos in this talk are from me, except for a few things taken offline. Okay, so outline. The first version of this that I did a year ago for the Black Canyon Astronomy Society, and then I was asked recently to repeat it for the Western Colorado Amateur Astronomers, so I did that about a week ago for the Grand Junction group, and so and I've revised it again, so this is the third time I've done this. So for this talk, compared to previous talks on astrotourism, I decided to organize it chronologically, century by century, and see how much of the development of telescope history I could describe with all of my travels and photos. We'll end with one interesting place in the USA. Okay, so let's begin with before telescopes. I visited Stonehenge. We all know Stonehenge, and it's an example of structures that were aligned to the sky, and there are many, many examples of that in ancient people going back thousands of years. Other good examples are Chaco Canyon and Machu Picchu. So people have been observing the sky for thousands of years. I thought of some other examples and some photos I have in places I've visited. In this slide, the Muslim astronomers had various instruments, astrolabes, quadrants, and globes. This illustration was from the British Museum in London, and so they observed the sky with their instruments. A lot of people in Europe made astronomical clocks. This is a famous one in Prague from 1410. People also made sundials a lot, an example from France. And one of my favorites, and this came up last year with the solar eclipses, the Babylonians, over 2,500 years ago, started recording information about solar eclipses on clay tablets and developed this thing called the Saros cycles. So there are numerous examples of the ancient people observing the sky. So this picture shows a book of Copernicus's famous book on the revolution of the heavenly orbs, in which he proposed the heliocentric theory in which the sun is at the center of the solar system. And if you look on the left side, you'll see his proposal of the sun at the center with concentric circles for the solar system. And as the caption says, this triggered a debate among scholars for something like a century on what the true nature of the solar system was. Okay, then in the late 1500s, Tycho Brahe, a famous Danish astronomer, really moved the science forward by producing what at the time were the most accurate and precise measurements of the motions in the sky and planetary motions. I was lucky enough to visit the island of Ven, H-V-E-N, which is just off of Copenhagen in present-day Denmark, about 30 years ago at a big astronomy conference, and we actually got to see the remnants of Tycho's observatory. I don't have any photos from that because it was a long time ago, but the image on the left came from the Deutsches Museum in Germany, a model of his palace, so to speak, and the one on the right's an illustration of the observatory he had with instruments called Uraniborg and Sterneborg. So Tycho Brahe really moved the astronomy forward. And then in 1600, Tycho was hired by I guess he was called the Emperor Rudolf, I think II, in Prague, to come to be at his place. And there Tycho hired Johannes Kepler to be his assistant. And for a year or so before Tycho died, they worked together. If you go to Prague, there's a famous statue of the two working together, a very large statue, because they're associated with each other. And the bottom line was Tycho's instruments were mechanical, and they collected very precise information on the positions of objects in the sky, and Kepler continued on after Tycho died and produced his laws of planetary motion. In Prague, there's a few other interesting places you can visit. You can actually visit the house that Kepler lived in near the famous Charles Bridge, commemorated in the plaque in the upper left. Lower left near the Prague Castle and the hill above the river in Prague is the building that I understand that Tycho actually worked at while he was in Prague, and then Tycho's tomb is in a church in Prague. Okay, so let's move on to telescopes now. First, just to give you an idea of what astronomy was like in the 17th century, on various art galleries I've visited, sometimes I run into things that are interesting with astronomers. These are three examples, and you see things like celestial globes and other instruments. The one on the left is called an astronomer. The one in the center, cognoscenti in a room hung with pictures. That's just an excerpt. And a famous picture on the right by Vermeer called The Astronomer. So that kind of sets the stage for the beginning of telescopes. So the next slide shows Galileo, and a man named Hans Lippershey is generally credited with inventing the telescope in 1608. There are a couple of other reports that maybe some other people had produced a telescope before that, but they're not really well documented, at least to my understanding. Maybe somebody else knows better than I. So that's a famous portrait of Galileo, and the time I visited Florence, which was 2017, I was walking down the street, and lo and behold, there comes somebody who I assume was going to be a mime, and I can swear that's Galileo. So I caught a picture of him next to some Italian woman. So then and now, there's Galileo. Okay, so in Florence, there's a really fantastic museum called the Museo Galileo, or the Galileo Museum. It's shown on the left. The lower left is just a reflection on the river, the Arno River, I believe it's called, and bridges on the river. Florence is a really interesting place. And inside this museum, there's a fabulous collection of telescopes. So one of the first ones you see in the upper left, they actually have two of the telescopes that Galileo produced. Below those two telescopes is a lens, a very small lens, and a very elaborate mount frame. And at the bottom, a copy of Sidereus Nuncius, the famous book that he produced with some of his early observations. These are a close-up of those two telescopes, plus a bust of Galileo. And at the bottom, it's a reproduction, but it shows you the components of Galileo's very simple telescope. So for the objective, it had a convex lens, and for the eyepiece, a concave lens. And so the result of that was a telescope that could magnify up to something like 20 magnifications and actually produced an erect image. So quite a sensation at the time. Okay, the next slide shows a couple of examples of Galileo's objective and eyepiece, close-up of Siderius Nuncius, and we're pretty much all familiar with his discoveries, but even with this simple telescope, he could observe the satellites of Jupiter, phases of Venus. He couldn't resolve Saturn's rings, but he could see bulges. His observations of those satellites and the phases of Venus supported the heliocentric model. He could see mountains and valleys on the moon, see sunspots, and actually resolve the Milky Way into stars. So Galileo's simple telescope was a very major step forward. In the Deutsches Museum in Munich that I visited, they actually have a model, a reconstruction of his workshop. That was pretty interesting. And a copy of the last work that Galileo did called Discorsi, in which he had several people discussing his work. Now, Galileo's early observations of sunspots in the sun were produced in a book. This is a copy of the book that I believe I saw in London. And in it, you could see the sunspots. And in the bottom left is another old image by somebody named Scheiner, who also observed sunspots and made telescopes in the early days. The interesting thing about this is that Galileo actually believed that sunspots were a phenomenon on the surface of the sun, whereas Scheiner at the time thought it was something between the sun and the earth. And of course, Galileo was the one who was proven to be correct. Okay, so as I started collecting the information I'd found in various places in Europe, at some point I realized that the 1660s and 1670s had a whole lot of interesting happenings in both telescopes and observatories. So I made a slide summarizing these. The Italians, in the tradition of Galileo, continued to make all kinds of telescopes. I'll show you a few later. A man in Scotland, a Scottish man named James Gregory, invented another design called the Gregorian. I'll show you a diagram in a minute. And then that was 1663, but Gregory never built one. And then 5 years later, Isaac Newton created his first reflector telescope, the Newtonian design. That was 1668. And then Laurent Cassegrain, a Frenchman, produced his first design in 1672. And of course, Cassegrain telescopes are very common today, and especially Schmidt-Cassegrains. And a man named Robert Hooke, who was, this is an interesting story in science. He was basically an enemy of Isaac Newton. He actually built the first Gregorian. And finally, the two famous European observatories were founded. The first one in 1667 by Louis XIV in Paris, and then the Royal Greenwich Observatory in London, in Greenwich, 8 years later. So those 2 decades were very eventful. Okay, so for illustration purposes of those 3 telescope designs, I took some diagrams off of Wikipedia. So if you look at the top one is the Gregorian, and you'll see what happens in the Gregorian is that you have a telescope mirror, and they were made out of metal then, with a hole in the middle. Light comes in off the primary mirror and then passes through its focus off of a secondary mirror, which is, it's hard to see, that's concave, right? And then back to a focus on an eyepiece. The one in the middle is Newton's design for reflector. We all know what that is. Put a 45-degree flat mirror and divert the beam into an eyepiece. And finally, Cassegrain at the bottom, something similar to Gregory's, but it actually produced an image with a different secondary mirror. So one of the properties of these two Cassegrain kind of telescopes was that Gregory's produced an erect image, so it turned out to be quite popular, I think, and the Cassegrain did not. Okay, in Florence at the Galileo Museum, they had a really interesting display they called Perfecting the Telescope. And so there were about 20 telescopes in this display, from fairly small to fairly large. That biggest one in the center is probably 7 or 8 feet long. It was quite large. And the interesting thing I found about these was that they had these nested tubes, which we might call a telescoping tube these days, and that was a fairly common design. And there's also a close-up of a eyepiece set in the same exhibit. Okay, so let's move on to London. If you've ever been to Westminster Abbey, you've probably seen these. I've been there several times. First time I went in, started the tour with the audio guide, and looked down to my left, and amazingly, there's Isaac Newton's tomb. There's a picture of it in the upper left. Nearby is the tomb of William Herschel, probably the greatest visual observer ever, certainly one of the greatest. And below left, a monument to Edmund Halley, and elsewhere in Westminster Abbey. Second time I went there, near the same place they had put Stephen Hawking, and Charles Darwin and John Herschel were nearby. So if you ever go to the Westminster Abbey, find this place. So here's a picture of Isaac Newton. In the upper right, I summarized his quote, resume, unquote. We all kind of know this too: the theory of gravitation, the laws of motion, calculus, the first reflecting telescope, prismatic dispersion of light, so that's pretty impressive. And to my knowledge, there might be 2 of these that still exist. I'm not positive of that. I think the Royal Astronomical Society has one, but there's an image of one. It's very simple, original Newtonian telescope from 1668. In Westminster Abbey, there's a fabulous memorial to Isaac Newton, and I'll just read an excerpt from it. The language is fabulous. Here is buried Isaac Newton, knight, who by strength of mind almost divine and mathematical principles peculiarly his own, explored the course and figures of the planets, path of comets, and so on and so forth. And down to the very bottom, mortals rejoice that there has existed such and so great an ornament of the human race. So this is a fantastic monument to Isaac Newton. Okay, so let's move on to Paris now, and moving ahead in time a little bit. There's a fabulous museum in Paris. My French is not great, but it's called the Musée des Arts et Métiers. And basically what that means is the Museum of Inventions and Technology. And the interesting thing about this place is that the French revolutionaries in the 1790s are mostly known for the Reign of Terror and thought of as being bloodthirsty, but they were actually extremely supportive of science and interested in conservation. And so when the revolution started in the 1790s, they conserved a lot of interesting scientific artifacts, things like the laboratory of Lavoisier, one of the greatest chemists ever, and shortly after started this museum that's been going for over 200 years, supposedly the oldest of its kind in the world. And it has a great collection of science instruments, history of technology, and some astronomy things. So if you ever go to Paris, I'd highly recommend this one. Okay, so they start out, they had a replica of Galileo's first telescope. And when I did this talk in 2014 on Footloose Astronomer in Paris, what I discovered was, I did find some interesting telescopes, but what I discovered was a whole lot of interesting astronomers that did a whole lot of interesting and unusual and surprising things. And the stories about the astronomers were almost more interesting than the telescope information I found. So I won't go through that, but I'm just saying history of astronomy in Paris in the 1600s to 1800s, quite fascinating. I'll give a few examples later on. And so the Observatory of Paris was created by Louis XIV in 1667. And a lot of people are surprised to find that the primary reason that Louis XIV created this was to improve the measurements so they could determine longitude at sea much better than previously. And of course that relates to safety at sea, and if you control the seas then that was a huge advantage for any given country. So what Louis XIV did is hired Cassini, the famous Cassini from Italy. Jean-Dominique Cassini is a French version of his name, and he discovered a lot of things about the solar system with the unusual telescopes they put in at the Paris Observatory then. And this is a famous old picture showing what they called an aerial telescope in Paris early on, and they actually put long focal length lenses on these incredible long structures with eyepieces at the bottom up on towers. And that's an actual tower that they'd taken from Versailles from a failed water system. And this concept came from a guy named Hevelius who produced these aerial telescopes. And that's an image of one of those. So these things are just amazing that they could actually discover, they actually made them and could discover things from them. When I went through the Observatory of Paris, and I saw this in the distance, this big mirror, and I said, wow, what could that be? They didn't really have big mirrors then. And I discovered what it was a thing called the miroir ardent, which translates to burning mirror. And if you look at the black and white image on the right, they could actually point it and focus sunlight and start things on fire. So I guess they thought that was highly entertaining at the time. So they actually had that replica in the observatory. Now, Cassini was one of the people that Campani, one of the people who made lenses for Cassini's telescopes. This is an example of one of those of about an 8-inch aperture. And so this is an example of the kind of lens that Cassini actually used with very long focal length to discover satellites of Saturn. That was from Paris. This is from Florence, another example of an objective lens by Campani and another maker of lenses for eyepieces named Davini. And this one's only about a 4-inch aperture, but another famous lens maker. One of the most interesting things I saw in Paris at that museum, and I saw it again later in Florence, was this thing, which I call 17th century long green binos. It was actually a little binocular telescope. If you look at the lower left on the top picture, the aperture looks like it's about an inch. Very small aperture, have obviously very long focal length and eyepieces at the back, and by a guy named Carabini, or Caraban, depending on your language, and I actually saw essentially the same thing at 2 different museums. Okay, so at this point, let's move on, and about the same time period to London. Once upon a time when I toured the Tower of London, I was surprised to find an exhibit, and the exhibit was about the beginning of the Royal Greenwich Observatory. So the text at the lower left says that King Charles II decided to create the Royal Greenwich Observatory, and just like Louis XIV in France, his objective was the determination of longitude based on astronomical observations. And so he hired John Flamsteed to be the first royal astronomer for RGO, 1675. Okay, so before the pandemic, I visited the RGO, the Royal Greenwich Observatory, and there's a building called the Flamsteed House that they constructed way back then. It has 8 sides, and this picture was taken from roughly the spot where the Greenwich meridian is located, the prime meridian at 0 longitude, and from where we measure longitude and time. Now, I have two views of this room inside that octagonal room, the octagon room they call it. So this is a picture of somebody using a telescope inside that room back then, and I make a snide remark about the mount, but it was looking out a window on a structure that held the top of the telescope and held the bottom of the telescope on a thing that looked kind of like a sawhorse, and they actually made observations with a system like this. And when I visited the RGO, they had a replica telescope that had the same design. Telescope looking up that you could change the altitude in a very crude way and look through the bottom end over a support. So they used this for mapping star positions, and a lot of people are surprised to know that in the 18th century, determining longitude has been sometimes called the greatest science problem, and I call it the greatest, perhaps, practical science problem in the 18th century. And the reason is it's relatively straightforward to determine latitude, because that's just a matter of making observations and reducing them north-south, whereas longitude requires that you know the time very accurately, and in a ship at sea, that's very difficult. So it took people a very long time to solve that problem. So let's move on to the 18th century. Okay, so the next slide shows two photos I took at the RGO, and what this slide does is it contrasts two competing methods in the 18th century for determining longitude at sea. The one on the left is called finding longitude by the astronomical method, and the picture on the right is a picture of John Harrison, the famous clockmaker of the 18th century, who eventually, after decades and decades of work, finally produced a fairly compact and accurate clock which could be taken to sea and produce accurate longitude readings, or be part of that through the clock method. And the essence of the astronomical method was, as it says in the first paragraph, is that the regular passage of the moon through the stars effectively it acts like a clock. So if you have a very accurate star map and a very accurate determination of the orbit of the moon and observe the position of the moon with respect to the background stars, that can effectively be a clock. So that's, in essence, what at the RGO they were trying to do for decades, was produce the accurate star maps and studies of the moon which could support this kind of longitude finding at sea. And at RGO they had an exhibit that listed three key players in the astronomical method. Of course, Flamsteed was the first. I talked about him before, and he mapped out 3,000 star positions. And then Halley, who's famous for a lot of other reasons, did an 18-year study of the lunar motion relative to the stars. I've heard that his data was not very accurate, but he spent 18 years doing that. And eventually a guy named Bradley improved the instruments and the data. So if you're at RGO, there's several rooms with instruments they use to make their observations along the meridian. This is a quadrant in the Halley Transit Room from 1725, and that's an example of the kind of instruments they used at RGO. Okay, this comes back in that museum in Paris. Another thing that kind of dumbfounded me the first time I saw it, and I saw another one in another museum also. This is a mathematical box for astronomers and engineers in the 18th century. And of course, you know, centuries before our digital modern methods, and that just gives you some idea of the kind of thing they had to work with in the 18th century. Okay, this next slide comes from, of all places, the famous Louvre Art Museum in Paris, and I visited the Louvre many times, sometimes with those French study abroad students, sometimes on my own. And one day I was walking along a not very often visited section in the Louvre, and all of a sudden I came to this place, Exhibit Hall 41, Scientific Instruments. And so I went in and looked around, and there were various instruments, and including a nice reflecting telescope that I'm sure is probably the Gregorian design. But it was the caption that caught my attention. So I'm going to read that because it kind of summarizes the nature of things in the 18th century during the Enlightenment. Okay, it says, experimental sciences were the cutting edge in the 18th century. The reception of Newton's law of gravitation, observations of movements of comets, effects of electricity enthralled the public. So the public became very interested in science. Great aristocrat scholars, even high society leaders, flocked to attend physics demonstrations and followed the proceedings of the Royal Academy of Sciences. Many enthusiasts even created their own scientific collections, which they called cabinets, bringing together various kinds of science instruments of the 18th century, and some of those were produced here in this room. So that really shows you how things moved from the 17th century to a fairly small group of people to the public in the 18th century. Okay, before we move on to more telescopes, I just thought I'd show you one of my favorite things I did in that talk about Footloose Astronomer in Paris was 9 of those 20 astronomers on that previous slide I showed you were around in the 1790s during the French Revolution. So for fun, I made a summary showing what happened to the astronomers in the decade of the French Revolution. Now, the Cassinis were really interesting. There were four Cassinis in succession who were directors of the Paris observatories. They were called the Cassini dynasty. And the fourth one was the director of the Paris observatory. He came to odds with the revolutionaries and was resigned and imprisoned, and he managed to avoid the guillotine and was eventually went into exile, but he survived. So that was the end of the Cassini dynasty. Bailly and Bouchard de Saron, I won't talk about them in any detail, but they were both from the upper classes, and they ended up losing their head. Of course, Charles Messier was around then, and he continued on, so he did fine during the Revolution. Pierre Méchain is a famous astronomer, and he discovered about 20 of the objects that are in Messier's catalog of 110 objects. And so he and another astronomer named Delambre were assigned to go out in the field and do observations as part of a project they called decimalization, and then sometimes given the nickname in French of the fathers of the meter. So the meter, the definition of the meter I learned was it's 1/10,000,000th of the distance between the equator and the North Pole, and they had a measure of the meter, so it's about 39 inches, and so they sent these two astronomers off by triangulation to work their way north to south from the north side of France down to Barcelona to create the decade to hopefully produce a more accurate version of the meter. And in Paris at the time, they actually have 17 big stones that were that length of about 39.25 inches that people could use as a standard on what the meter was. I thought that was pretty interesting application of astronomy. The last three, Lalande, Lagrange, and Laplace, well, Lagrange is famous for the Lagrangian points, and Laplace famous for a 5-volume tome on celestial mechanics, which somebody said at the time there were only 25 people in the world capable of understanding it, but they were all exalted. So that was one of the fun things I learned in that whole exercise. So these are a couple of unusual 18th century telescopes I found in the museum in Florence. The one on the left is called a ladies' telescopes, and it's from the second half of the 18th century, made out of wood and ivory, a couple of feet tall, so it's pretty big. And it contains two telescopes, and it has ivory boxes in it for cosmetics and perfume. So if you're a high society lady with the money, you could actually buy this thing and carry it around. I thought that was pretty interesting. And then the right's a terrestrial telescope. Okay, the next slide, in the very first slide I showed some Gregorian telescopes. I actually saw in these museums quite a few Gregorian telescopes from the 17th, 18th, and the 19th century. And these are 3 examples I saw, 2 in Munich in the Deutsches Museum, and another one from an exhibit in Paris. And so just from the statistics of small numbers, I concluded that these were probably highly common in that time frame, probably partially because they had erect images. Okay, I only saw one Cassegrain telescope, and that's at the museum in Paris on Cassegrain's design. This is that telescope. Okay, so let's move on. I'm going to show you an example of kind of science that some of those French astronomers did that kind of blew my mind when I discovered this. Okay, so one of those 20 people was a guy named Lemonnier. And a lot of people have heard about the Da Vinci Code, of course. In the Da Vinci Code, they go into this famous church in Paris, the Église Saint-Sulpice. But that church is famous and interesting for a number of other reasons. One, it has probably the very best organ in Europe, but the other reason is that it has the gnomon. And the gnomon, if you look in the upper right, you'll see in that big window, you'll see a little dark spot in the upper right, and that had a pinhole, basically. So the pinhole acted like a camera and projected an image of the sun onto the floor of this church, in the front of this church. So if you look at the center photo in the bottom, on the left-hand side, in the stone on the base of the church, is the meridian line going all the way across the front of the church. And on the right is an image of the sun projected by that gnomon from that window up in about 75 or 80 feet above the base of the church. Okay, the final part of this thing is in the lower right, you'll see a picture of an obelisk on the far side of the front of the church, and that's a picture of me standing in front of it. So you can see this thing must be about 30 to 40 feet tall. So what happened was, in the course of the year, as the sun went from being far south in the winter to far north in the summer, the image that it produced on the floor of the church worked its way all the way across from one side of the floor along the meridian, all the way across and all the way up that obelisk. And at noon, it crossed the meridian. So the next slide is a summary. So this astronomer named Pierre Charles Lemonnier, actually for 46 years straight, he went there, observed the position of the sun at noon on the summer solstice, and he computed two things. The first thing in the top of this slide was that the actual size of that image of the sun varied by a small amount, and that was because the orbit of the Earth is not perfectly circular, right? It's a little bit elliptical. So as time went on during the year, the actual image of the sun changed. And so he could determine when perihelion occurs, and it's in January, I believe, when the image was the largest. And in the bottom, because the path of the sun varied a little bit over his 46 years of doing this, he was actually able to calculate the variation of the obliquity of the ecliptic. And that's simply the angle between the orbit of the Earth's around the sun versus the inclination of the Earth's rotation. So that was amazing. All right, so let's move on now. Okay, so the next slide shows an image of a refractor by a fairly famous telescope maker of the 18th century called John Doland, and in London. And John Doland was the one who commercialized the achromatic lens. So the original concept came from a man named Leonhard Euler, and Doland commercialized it and produced the first achromatic telescopes. Upper right is a diagram showing how when you make two lenses of crown and flint glass, different glass with different properties, and make them in the right shape, they can actually bring two colors of the spectrum, usually called C and F, H alpha and H beta, to a common focus. And of course, up until this time, for about 150 years, refractor telescopes suffered from serious chromatic aberration, and they often overcame that by making very, very long focal lengths. And one other thing I discovered, that Doland's son actually came up with the invented concept of the triple achromatic lens, which we now use the term apochromat for. And so originally an apochromat actually brought three colors of the spectrum to a common focus, not two. And today, with all of these wonderful new ED lenses and so on, very high performance lenses, we commonly take an apochromatic lens to mean just one with very low chromatic aberration, but that's where the term originally came from. Okay, Charles Messier. Okay, Messier began observing, I think, in the 1750s, and he was hired to be part of the Naval Observatory. The Naval Observatory used small telescopes to make astronomical observations, also for use by the Navy. And it turns out that where Messier observed was on that tower you see in the center of the image on the right. And that place is called the Hotel Cluny, and it's an ancient building that goes way back to almost Roman times, I believe. And currently that building is the French National Museum of the Middle Ages, but in the second half of the 18th century, Messier had his telescope on top of that and observed from it. And of course, at the time, it was before electricity, so a lot of the skies were dark and part times of the month. And I don't know that any of his telescopes survived, but that was one of the places he primarily observed. I also went to the famous Père Lachaise Cemetery, and that's a picture of his grave and monument. Another really unusual thing that I discovered in this museum in Paris was a thing called Chapp's aerial telegraph from 1794. And this is an early example of using semaphores to communicate among people separated by several miles, for example, an army. So you could have a tower at one place giving signals and a telescope at the next group down the line, some number of miles presumably, using that telescope to zoom in on the message they were sending. So an aerial telescope doing semaphores. Okay, so let's finally move on to Bath and William Herschel. The Herschel Museum is in Bath, England, and I had the pleasure of going there right before the pandemic, and this is a pretty amazing place. This is where Herschel was living in 1781 when he discovered Uranus in the garden or the backyard of his house in Bath, England. And so this is an image of a portrait of Herschel. As in some of my photos, you can see my reflection as I'm holding the camera off the glass in front of the portrait of Herschel, and the several plaques on the Herschel Museum, and his famous quote that I have looked further into space than ever a human being did before me. Okay, so in the Herschel Museum, they have a replica of this telescope. They called it a 7-foot telescope because they often referred to telescopes by their focal length, not just their aperture. And this is a replica of the telescope he used to discover Uranus in March of 1781. The caption says that the original telescope is still owned by the family, and this was a model made back in early 1980s when they opened the museum. The Herschel Museum also had several interesting models, and the one on the left is a model of his famous 40-foot telescope. And basically what happened with Herschel was he became so famous after discovering Uranus that King George III hired him to be his personal astronomer. And George III was very interested in astronomy, and when that happened, Herschel moved to the town of Slough, which is just across to the north from the Thames River of where the Windsor Castle is, where the British kings had lived for many centuries. And then that model shows the way it was mounted, and I don't know if you can see it, but there's a little stick figure of a man peering into the telescope. So this thing was so bulky and hard to use that it didn't really get used much, and eventually it went into disuse, and Herschel actually built an approximately 20-inch reflector. It says 18.7 inches here, and that was his favorite and the one he did a lot of his work from. Eventually, at the Herschel house in Slough, I believe a tree fell on the tube and destroyed part of it, and they took the lower part, which would have contained the mirror, and put it on the grounds at the Royal Greenwich Observatory. And so you can see from that image, it's quite large, and so the remnants of his 40-foot telescope still exists. One of the really interesting things in the Herschel Museum that it was completely unexpected to me was this illustration of how Herschel made his mirrors. And they were speculum, which I believe is an alloy of copper and tin. And so in the upper left are two of his metal mirrors. In the upper right is a replica of a mirror machine he made for grinding his mirrors. In the lower left is an example of the furnace they used to cast mirrors before polishing them. And on the right is a lathe they used called a treadle lathe, which I believe was operated by your feet to turn it, which they used to make metal parts and small lenses and things like that. So one of the great things about Herschel was he was not only a great observer, but he was endlessly building his own equipment, better equipment, and that was one of the keys to his success. So this next slide is pretty entertaining, I think. Okay, this is a caption that was in that section, and Caroline Herschel, his sister, was of course with him at the time. It says, Herschel had a furnace installed and the mirrors were cast in a mold containing horse dung in a wooden frame. Lovely, eh? The workshop would have been a very hot and smelly place to work. Disaster nearly struck one day when molten metal leaked out of the furnace into the fire and onto the floor. The flagstones it hit shattered and flew everywhere. Caroline Herschel recalled, both of my brothers and the caster and his men were obliged to run out at opposite doors, for the stone flooring, which should have been taken up, flew about in all directions as high as the ceiling. My poor brother fell exhausted by heat and exertion on a heap of brickbats. So again, this kind of takes you back to a different time and different world of telescope making. The museum had various other artifacts. These are small telescopes, a sailor's telescope, a soldier's telescope, some prisms, eyepieces, mirrors, and so on. So it's a lot of interesting things in the Herschel Museum. There was also a thing that had a family tree, and so Herschel's in the upper left, his sister Caroline in the upper right, and of course his son John Herschel is a very famous scientist and astronomer as well. And John Herschel was the one who founded the Royal Astronomical Society, and this is from their building in London. One of the other things about Herschel that a lot of people don't realize was that for half of his life, he made his living as a professional museum. So he came from Hanover in Germany when he was around 19 or 20 years old, as part of an orchestra, and eventually ended up in Bath. He was very talented, obviously. He became the director of music in the town of Bath. Bath was a very, very upper-class, high-end town in Georgian society in 18th century Britain, and so for a long time he conducted concerts and performed on the violin and viola and various things. So there's a section on the museum that honors his life as a museum. Caroline Herschel was also a musician, and there are things like posters where William Herschel is conducting the orchestra and Caroline Herschel is the soloist, and so on. So it's pretty interesting. But finally, he got so interested in astronomy that became famous that the musical life he left behind. And that's just a telescope in the Herschel Museum. Okay, we'll basically skip over this, but one of the things I did after visiting the Galileo Museum is go through all the captions and made a list of all the makers of telescopes from the early days in the Galileo Museum. They're virtually almost all Italians, and there are all kinds of interesting old telescopes in the Galileo Museum. Okay, probably my favorite room in the Galileo Museum was this room, and we've got two slides from this room. And so these are telescopes from the 18th century in Florence in the Galileo Museum. So, okay, first of all, on the left, note the woman for scale. So the perspective makes the telescopes look a little bit bigger. But the four telescopes, the one on the left is called the Amici 2, I guess that's how you pronounce it, refractor, a very long refractor with a beautiful wooden tube. The three on the right are Newtonian telescopes, and I have close-ups of those. They were so fascinating to look at. Well, while they're all together, look at all those interesting mounts and how unusual they are by today's standards. Okay, so the next one is a Newtonian anonymous. Had a metal mirror, basically an 8-inch Newtonian reflector with an octagonal tube. And just like all four of these, the woodworking and metalwork is just exquisite. They're almost works of art. The second one has a round tube. This one's also anonymous, about an 8-inch reflector. And it had a rope and pulley for changing its altitude. And the third one, actually by a guy named Leto Guidi, 1766, and it was different design. It almost looks like an Altaz mount of today, and beautiful. Okay, moving to the 19th century. Okay, on the left side of that room was, again, one of my favorite telescopes. The one on the top was another telescope by Amici or Amici, however you pronounce that, from the early 19th century. It's almost 20 feet long. It was a beautiful thing. There were also more Gregorians. Like I said, they were very common. So more Gregorians in the Galileo Museum. All right, so finally let's move on to the 19th century. Okay, so for context, I made a reference to basically before the 1900s and after. So before the 19th century, a lot of astronomy was simply focused on celestial mechanics and astrometry. So they computed orbits a lot from planetary observations, observations of comets, satellites of Jupiter, things like that. Spent a lot of time modeling those with celestial mechanics. And they also did a lot of astrometry, meaning a lot of their observations were simply to catalog stars, measure their position, and make catalogs of not just stars, but for example, in Messier's catalog and a lot of Herschel's works, they were galaxies, planetary nebulae, star clusters, and other things. And they simply, at the time, had no idea physically what they were. Well, finally, in the 19th century, that was really the beginning of the age of astrophysics. So spectroscopy began in the early 1800s. Photography, of course, a little later, first part of the 1800s. And a lot of instrumentation developed and great advances in technology in general. And so because of this, they really started to begin to understand what some of the objects they were seeing were. Okay, this slide is from the Deutsches Museum in Munich, and I found this fascinating. This was an exhibit of glass and prisms from the famous Joseph Fraunhofer. Now, Fraunhofer in the early 1800s was the one who made great advances in glass, which of course helped produce better telescopes, and prisms, and which contributed to producing spectroscopes, which he did. And on the top is an example of the solar spectrum. So he was the one that observed the absorption lines in the solar spectrum that have the common names we use today for A and B, which are the atomic bands of diatomic oxygen, C and F, which are hydrogen alpha and beta, magnesium and iron, the G band, H and K, calcium, and all of those things in the solar spectrum. Okay, so I guess this, probably of all the telescopes I saw, this has to be number one. So in the Deutsches Museum in Munich, this is the telescope that was used to discover Neptune in, I believe it was 1846 or 7. Sometimes I forget. So probably a lot of you know the story of the discovery of Neptune, but I'll summarize it. So an astronomer at the Paris Observatory named Leverrier predicted its existence, and he did it because there were anomalies in the orbit of Uranus. And so they theorized that there must be another planet out there. And so Leverrier was able to model this mathematically, predict where that planet would be. He produced these predictions, and lo and behold, an astronomer, I believe his name was Galli, in Germany, looked there and he discovered Neptune with this telescope. There was also an astronomer in Britain named Adams who basically made the same predictions, but the English didn't have their act together like Leverrier and Galli did, and so they didn't discover it. But this telescope discovered Neptune. It's a 9-inch refractor. You can see the picture has a person in it for scale, and this is a close-up of it. It may be kind of hard to see, but again, the metalwork, the woodwork, everything is just unbelievably beautiful in this telescope. Okay, continuing in the 19th century, Foucault is another famous scientist and astronomer. He's famous for a lot of things. Of course, the pendulum, the Foucault pendulum, which I've seen several times in Paris, was due to Foucault. He was the one that did the famous event, and I believe it was 1851 in Paris, where he invited all these dignitaries to come to see his pendulum, and he described it as to come see the rotation of the Earth. Because as the pendulum goes back and forth, it slowly moves around the objects underneath it, which of course is due to the rotation of the Earth. He created the parabolic mirror test that's commonly used in parabolic mirrors. He applied the silvering to glass telescope mirrors, which was an advance. He measured the speed of light. There was the gyroscope. I mean, he had an incredible resume also. So this is one of his telescopes I saw in the Paris Observatory, 16-inch aperture. It looks kind of like a modern design too. I saw a London exhibit on the sun. They had this beautiful thing they took to eclipses. We won't say much about this, but let's move on to the discovery of helium as a fun story. So this slide was taken from some videos in the Science Museum of London when they had a big exhibit about the sun. And so on the right is an example of a spectroscope that Norman Lockyer produced, and an example of him using it. So in 1868, this great solar eclipse occurred, and Lockyer saw lines in the spectrum that they hadn't recognized from before, and so they named it helium because they were from the sun. Meanwhile, an astronomer in France named Jules Janssen also discovered the same thing at another place, I think, in the same eclipse. And so if you're in Britain, they give Lockyer credit for discovering helium. If you're in France, they give credit to the Frenchman, of course. All right, so we're getting pretty close to the end. So this is a place near Paris called the McDonald Observatory. This guy, Jules Janssen, was a famous French solar astronomer who for about 4 years did all kinds of research on the sun, in imaging, spectroscopy, instrumentation, all sorts of things. And in 1876, he created the McDonald Observatory, and this is a picture I took of it. And this thing's really unusual. It was on the side of an earlier chateau from the French kings that had a big fire, and the fire basically destroyed the second floor. So the first floor is the remnants of the chateau from the French kings. The second floor was lopped off, and they built this observatory on the top of it. Okay. So this is probably the most unusual thing you'll see in this whole talk. This is the Solar Observatory at Mont Blanc. Now, Mont Blanc is the highest point in Europe. It's 15,800 feet. And one of the things Jules Janssen was interested in was trying to understand the O2, the diatomic oxygen in the spectrum that he saw in the sun. And to try to separate it out between whether it was from the sun or from atmospheric or what we call telluric lines. He wanted to observe the sun at higher and higher altitudes. So he convinced the French Academy of Science and another organization, Paris, to fund the building of this observatory at the top of Mount Blanc, which is an ice world almost 16,000 feet up. So they built this observatory. It was finished in 1893, used for over a decade. And they had a 12-inch refractor in it for a couple of years, various instrumentation. Janssen was only able to go there 3 times because he was really difficult. He was a fairly old man. And eventually this thing gradually sunk into the ice. So finally, by about 15 years later, they had to dismantle it, take it down. But they did do solar observing for quite a while there with various researchers. Okay, this is a picture I took. This is a place we went with the French students a lot. Below is the Valley of Chamonix. On the side from the photos, not nearly as high. And you can see in the top center, I put a circle around Mont Blanc. You can see a big glacier going up to Mont Blanc. On the left is a big promontory called the Aiguille de Midi. The Aiguille de Midi is at 12,600 feet. And so Mont Blanc is over 12,000 feet above the valley floor of Chamonix. And so to produce this thing, they had to mount expeditions carrying all the parts up to the top of Mont Blanc. Final slide. Very recently, I discovered a paper by an astronomer at the Paris Observatory all about this expedition and what they did. The picture on the left is a picture of the route they had to take to get up the glaciers and through all the way up to Mont Blanc to carry all the equipment and materials to build this observatory. And the one on the right's incredible, showing how they had to had to build bridges across ice crevasses and so on. So it was incredibly dangerous and difficult to do. This paper talked about how to actually carry the material for that structure up there. He called it 800 man loads. So it would have taken 800 people carrying one load up there, or let's say 40 people carrying 20 loads, all climbing Mont Blanc up to almost 16,000 feet. So if they could create this thing in those kind of conditions is amazing. Okay, so that's the end of the Mont Blanc Observatory. A few more things. The Area Transit Telescope at RGO from the 19th century. They kept building better instrumentation at RGO and refining the accuracy of the meridian. And final image from RGO. The 19th century, the latter part, was the era of the great big long refractor telescopes. This one was a 28-inch at RGO. There are famous ones in the U.S., the 40-inch and 36-inch at Yerkes and Lick Observatory. Of course, the Chamberlain Observatory has a similar telescope. And so that was the era of the great refractors. A couple more telescopes in Lyon, another reflector by Foucault, refractor by Bardou. Okay, another one of the more interesting telescopes I saw in the Lyon Observatory. Lyon's the second or third largest city in France, depending on how you count it. And that's where most of the work was done with these French study abroad students. So I spent a lot of time in Lyon. Went to their historical observatory from the 1880s. They had a Coudet telescope, which tracked objects with this interesting optical arrangements and brought the light to a fixed focus, which is shown in the upper right. Very unusual telescope. And I had to put this in just because it's such fun. When we visited the observatory in Lyon that time, they actually had an art display. A group of art students had taken a telescope of about, an antique telescope of about 20-inch aperture and painted it and decorated it and turned it into an art telescope. Really cool. 20th century, not much here, but I'll go through quickly. Obviously, very little in museums. Most of the main things of 20th century astronomy are at places like Mount Wilson, the 60 and 100-inch telescopes, the 82-inch telescope at McDonald from the 1930s, and so on. But they did have in the Deutsches Museum in Germany the first active telescope mirror. It's not adaptive yet, but a telescope which actually used actuators and wavefront sensor to measure deformations in the incoming wavefront and modify the figure of the mirror to try to correct for deformations in the image. They also had a model of the ESO Extremely Large Telescope, which they're building one in Chile now. Okay, final thing. I actually went to the Einstein house in Bern, Switzerland once, back when we were much younger. And you can actually visit the place in Bern, Switzerland, where Einstein worked. For completeness, some other places that I either went to or wanted to go to. If you go to the Hamburg Observatory I went to once, they actually have the Schmidt Museum, the famous Bernard Schmidt, who invented the Schmidt corrector, and common in Schmidt-Cassegrain telescopes now, worked at that observatory, and there's a little museum with his prototypes and documents and things. Pic du Midi's famous French mountaintop observatory in the Pyrenees, spectacular place I wanted to go to, but haven't been able to yet. The observatory of Haute-Provence is the place where they discovered the first exoplanet, 51 Peg. Cambridge and Oxford have good science museums. The famous Leviathan of Parsons, Lord Rosse, 72-inch reflector, which was very bulky and unwieldy and not very productive, but was the one where they first saw the spiral structure of the M51, the Whirlpool Nebula. The remnants are there, and there's a great refractor in Potsdam. Okay, almost done. That's the end of the talk, except for my addendum at, of all places, the South Carolina State Museum. Now, maybe some of you have heard of this. Has anybody heard of the museum in South Carolina? Okay, I only heard of this, 8 or 10 years ago because we have a friend who was a French professor who got hired there as a French professor at the University of South Carolina. So we thought, well, we might go visit her someday. So I Googled it, and lo and behold, there's this museum with the historical astronomy exhibit in Columbia, South Carolina. Okay, so this is the museum. You'll see a dome on the top, up on top of the 4th floor, the entryway with the Robert Ariel Historical Astronomy Museum. So there was this man named Robert B. Ariel who developed this amazing collection of historical astronomy telescopes and instruments, over 200, and that's summarized on the left. But on the 2 diagrams on the right were really interesting. So the upper right one shows the dome on the 4th floor and this very large metal triangular structure that supported the mount of that telescope. And the lower right one shows when you go into the lobby of this museum, you see this large metal triangular tripod structure. You wonder what that is, and then once you finally get up to the top, you understand that that's the support for the observatory up on the roof, which has a 12.5-inch Alvin Clark refractor that's been reconditioned and modernized. Okay, the one cool telescope there was this man, Robert Ariel, was obviously an amazing guy who renovated telescopes. So he collected them, and this is a 5.6-inch refractor by a maker named Henry Fitz, and another one beautiful thing from 1849, on the same level as those telescopes we saw, like the Neptune Discovery Telescope. So there are lots of displays of Alvin Clark's and other historical telescopes. So next to last slide, up at the top in that dome, they have a Alvin Clark 12-inch refractor from 1926 that's been renovated, and they use it for public outreach. So we're finally at the end. For a summary, I made a summary of the 12 places in Europe that I visited and from which all of the material you saw and photos and various things were taken, and add Columbia, South Carolina at the bottom. So that's the end. Thanks for listening, and perhaps you have questions. First question.
Wasn't Carolina?
Oh, microphone.
Wasn't Caroline Herschel an astronomer?
Yes, she was. She was not originally. And what I learned when I went to the Herschel Museum and did a little research was she was the younger sister of William. And when he went to England, she did not go with him initially. And she apparently had a really pockmarked face and really had a bad appearance. And William thought that she would never be married and have a family or anything, and she would just end up being a servant for somebody because of her appearance. So to help her, he brought her to England to be his assistant. And it turned out she was an excellent musician, just like William was. So for a number of years, they were part of the high society music life of Bath. And then originally she was his assistant. Obviously, in those days, you took notes at the telescope, you recorded, azimuths and time and all this sort of thing, and reduced it. And she evolved into an astronomer in her own right, made her own discoveries. And I guess I'll end my answer with one of the famous ones. NGC 7789 in Cassiopeia is one of the really nice, rich, open star clusters. That has the nickname Caroline's Rose. That was one of her discoveries. So she turned out to be a pretty good astronomer, and she lived quite a while after William, and to my understanding, she helped preserve some of what he did. Mm-hmm. I see one in the back right.
Two-part question. Can you hear me?
Yes.
Two-part question about sunspots.
Mm-hmm.
Do we have any indication that Galileo tried to protect his vision? And two, were his observations historically accurate? Do we rely on them for the history of sunspots?
Okay, as far as the first one, of course, I have no knowledge that he blinded himself, so we assume he he managed to do that without hurting himself. Of course, just like today, you could project an image through a telescope, look at it that way, and that one image I showed from the astronomer named Shiner, he actually had a fairly elaborate thing to project the image. So I assume the standard way to do it was by projecting the image. I haven't verified that, but I think that's the case. As far as accuracy, I have no reason to believe that they were not accurate. His drawings are really impressive. When I saw that book in London, they looked really good. If you look at, there's a famous graph showing 400 years of sunspot history that a lot of people have seen. So pretty early on in the 1600s, they started recording information about the number of sunspots and all that sort of thing. So our record of sunspot activity based on the kinds of observations that Galileo did really does go back 4 centuries. So I think they're, bound to be pretty accurate.
There was a slide that talked about King George III, who had a personal astronomer.
That's right.
And I wanted to know what would the king need a personal astronomer for? Was it for actual? I don't know. You tell me.
Yeah. Why would he have a personal astronomer? Well, I guess my first reaction to that question is just like that slide from the Louvre. People in the 18th century and the Enlightenment, especially the upper class and the ones that were educated and all that sort of thing, developed a broad range of interests. Some of those astronomers I showed in that, the 9 astronomers in the French Revolution. One of the ones that ended up getting guillotined was a lawyer. He was kind of head of the legal system in France. He was also an optician. He made lenses. He computed orbits for comets that people like Messier discovered. So you look at what this man did and you say, wow, he's like a Renaissance man in the Enlightenment. So I assume George III had this broad set of interests. My second comment is, a number of years ago, before we took a trip to London, I did a little research on, what are interesting places in London to go and, look for astronomy. And there's a building that I believe was actually King George III's observatory once, somewhere out in the outer part of London. I forget which castle it was or exactly where it was. And it's no longer a place you can, does astronomy or you can visit. So I think he was just a curious man. Give him credit. He was, well, I guess I'll answer that in one more way. Is one of the things I discovered, and several of the ones in that slide about the French Revolution, like the guy just described that was the lawyer and comet orbit builder, et cetera, were fairly wealthy. Those people tended to be from well-to-do homes. They were highly educated, and they became patrons of astronomy. And so you have to give them credit for supporting the people doing the work. And so I'd give George III credit for being a patron of William Herschel, an important part of the development of science, and the Medici too in Florence. All of those things that they saved over a long period of time. Any other questions? Okay. That was my son-in-law, by the way. This is my daughter, and they live in Lakewood, so I'm here visiting them.
So what's your next trip going to be? Out of all those places that are still that you want to visit, what's your next one going to be?
I'd love to go to the Pic du Midi, not just because it's an interesting historical place where a lot of great planetary images were done a long time ago, because it has great seeing. It's on a rocky mountaintop in the Pyrenees with a fabulous view. Has a gondola, you can go up there. There's other science instruments up there. And that's the first one that comes to mind. But it's like a 6-hour drive from Lyon where we spent our time. So you have to be in that part of France to go to the trouble to go to the Pic du Midi. So I think that's an obvious one. Not just for astronomy, but for the general touring, entertainment. Anyone else? All right, well, thanks again for listening. So let me stop sharing. Where do I do that?
It's already stopped.
Oh, it's already stopped, okay. So let me get out of that.
Lots of accolades in the chat for you.
Oh, okay, thank you.
This is working fine.
That's so weird. It won't work with the other.
I figured out what it was.
Oh, okay. And my mouse.
You want your mouse?
Have you found any evidence? I think I think it said, have you found any evidence that Ben Franklin communicated with Messier? And the answer is no, I haven't, but it would have been quite possible. One of the things I did in Paris was walking tours of various kinds. Lots of famous people like Ernest Hemingway and Frederick Chopin and on and on. And so I did some exploring about Benjamin Franklin. And he went there well, basically he was in Paris for the entire American Revolution. And what he did is he periodically went out to see Louis XVI and raise money, which got sent back. And that's one of the reasons why the Americans won the Revolution, was the French were supporting him. So he was there from mid-1770s to the mid-1780s, and that was the time when Messier was there. Not only Messier, but a lot of these other famous people like Lagrange and Laplace, and so I wouldn't be surprised at all if he interacted with them, but I have no knowledge of that. He was a scientist, of course, so you would think they might have been interested in seeing each other. I should look into that. That's an interesting question.
Well, thank you again. That was fascinating. I've been to Greenwich, and it is an amazing place. And actually, Pavlina Karafelis, one of our board members, was there just recently. She sent me a photo of herself there. Are there anything in the chat? Okay. Well, thank you again. It's fascinating. We appreciate it.